Camera calibration is important for achieving accurate results in PhotoModeler. The purpose of camera calibration is to determine the exact values, such as focal length and lens distortion, for your particular camera. While the techniques and procedures are similar, if the size of your modeled object is less than about a foot, you should use a single calibration sheet. See the separate single sheet calibration tutorial. If your object is larger than a foot, you should use the multi-sheet calibration outlined here. To fine-tune the camera parameters for projects any size, see the field calibration tutorial. The first thing you need to do is create the calibration sheets. Go to File, Print Calibration Sheets, and choose the multi-sheet option. The target size can be adjusted, so the smallest target should be at least 10 pixels across in any image. In this case, our targets need to be about 13 millimeters. Print enough sheets to cover your calibration area. The size of this area will depend on the focal length of the camera and the distance of the camera from the sheets. Lay the sheets out to form a calibration area. You can optionally raise or lower some of the targets. This added depth to the calibration area can be especially useful with longer focal lengths. Make sure your sheets are fixed down so they will not move between photos. Even a small breeze caused by walking can affect the target positions and result in calibration. Here is an example of a calibration area and the required photo positions. First, a set of photos is taken from each side using a landscape orientation. All camera settings, such as zoom, resolution, and image quality, must be the same for all photos in the calibration project. You should also turn off sharpening and image stabilization or any other post-processing operations. Now, a portrait photo is taken, meaning the camera is rotated 90 degrees to the right. 4 more photos are taken. Fill up the window as much as possible. You do not need to fill the entire image in every shot, but try to have each part of the lens covered in at least one shot. All targets must be in focus. If you're having depth of field focus issues, as targets in the front are in focus, but not the ones in the back, or vice versa, try decreasing the aperture. That is, increase the f-stop number. This will increase your exposure time, increasing the need for a tripod and good lighting. This time, we rotate the camera 90 degrees to the left and take our last set of 4 photos. If your lighting is good and you have a fast exposure setting, you may be able to take handheld photos instead of using a tripod. However, any motion blur will decrease the accuracy of the marking, so when possible, we recommend using a tripod. With a good set of images taken, we can transfer the image files to a folder on our computer and start the calibration. To start the calibration project, we click the New Calibration Project option on the Getting Started dialog. We navigate to the directory where we saved the images from the camera and add them all to the project. A multi-sheet calibration is detected, and we can hit Run to perform the calibration. First, auto-marking detects the target points. Then processing solves for the camera parameters. The final step is checking for high deviations or correlations. If one is found, a parameter may automatically be removed, as it is not having a beneficial effect on the project. Next, we will do some verification of the calibration results by clicking Show Report. First, we will look at the problems and suggestions area. There's a warning here as the correlation between principal point Y and P2 are just above the 95% threshold. This can be quite common. If your calibration fails or you have other warnings or error messages, refer to the help file or contact technical support. The next section gives us information about the calibration process. We check the total error. With a high quality camera and fixed lens, you should have an ending value of around 1 or lower. The camera used for this tutorial had a zoom lens, which is less stable. The minor inconsistencies give a slightly higher total error. This is an acceptable error for this camera. If the error is much larger, there may be an issue with your photos, such as the grid was moved between shots or there are blurry targets. Next, we look at the precision and standard deviation section. This is the list of the camera parameters that were solved. The focal length shows a value of 12.47 millimeters. Note that it is the relative size of these parameters that is important, and not the absolute size. So if these parameters do not appear to match what you expect from the camera specifications, it could be that the format size does not match the true size. That does not mean the calibration is incorrect. The quality section should be studied to review how strong the calibration was. First, we will look at the point mark residuals. We open this section. A residual is the difference between the marked 2D point location and the projected 3D point location. The important number here is the maximum residual. This tells us that the maximum marking residual is 5.53 pixels, or less than half a pixel. As a guide, the maximum residual should be under 1.5 pixels. All residuals should be under 1 pixel in a good project. The lower the number, the better. This is the overall root mean squared error of all the pixels. The value of this should be under 0.5 in a good project. We finish our review and close the camera calibration dialog. The calibration is now complete, and we have the option of adding the camera to the camera library. When importing photos for use in a project, PhotoModeler will use the data in the image header to automatically match up the images with cameras in your library. We will click Yes to add the new camera now. Cameras can be added and removed from the library at any time. Another way to check the results is by reviewing the photos and their marks. We click Select All and Open. This opens all the photographs. We turn on Residual Display, and each mark point on the photo will show a black bar starting at the mark point and going off in some direction. Where the black bar ends is where PhotoModeler thinks the mark point should be. In a well-solved project, these mark residuals will be very small. We will increase the exaggeration factor to 2000 pixels. This increases the size of the bars to help us look for error patterns. A bad pattern will have all residual lines pointing in one direction, all towards the center, or all pointing away from the center. We make sure the patterns on the error bars are relatively random, and there are no patterns concentrating in small areas of the photographs that might indicate a problem. We have done a number of checks to review the calibration. First, our final error number in the processing log was around 1. Second, in the status report, we checked the maximum residual, overall RMS residual. The smaller the numbers, the better, and some standard deviation numbers. Third, we checked the residual errors in the marking residual display to look for patterns. We can save the calibration project. This PMR can be used to load the camera if it is not been added to your camera library. This concludes the camera calibration tutorial. In this tutorial, we have learned how to print sheets for calibration, how to take proper photographs for use in calibration, how to run a camera calibration within PhotoModeler, how to review the camera calibration, and how to save the camera for use in our projects. A well-calibrated camera is the best way to ensure high accuracy for your PhotoModeler projects.